Well, my name is Rex Selentine. I'm the Technical Marketing Manager for the automotive products at Autodesk. With me is Ananda, who's my cohort in crime. I tell him all the things that he's saying wrong on the website so that we fight against each other all the time. But Ananda's the Product Marketing Manager, so we work side by side. Let's see. As soon as I can figure out how to make this go forward. There. I've been in the industry for a long time. Mike will attest to the fact that I used to work for Alias before it was acquired by Autodesk. In this class, there's kind of this question mark as to what do you do with conceptual data. And so in this class, we're going to look at speedform data and how it's used downstream, so into the detailed design portion and other avenues. I wanted to make sure that I did a good job talking about multiple ways that the speedform data can be used in a general workflow. And before I go there, most people like something free. Anybody like free things? So I think so too. So there is, if you go to this location right here, it does say sim at the end. Don't worry, they won't ask you to try to do some finite element analysis. But what you'll find there is that if you go through that scavenger hunt, you'll be in for the ability to win nice prizes. I mean, like $1,000 watches and really nice stuff. So I suggest you go there. Something for free is better than paying for it. So when we're talking about the industrial design process, I thought I'd at least put this map up here. Do you want me to put it back? Can you go back? I can. Well, I will try to make it go back. Stay. So ninjasandbits.com. Take a picture of it. I mean, seriously, they have, I think, a watch that's right around the $1,000 mark that's being done here. So all you have to do is find those key things, and I can tell you a couple, but that'll cost you extra. So in this class, I thought it would make sense to at least define the scope of what I'm talking about. And so you have sketching, the classic industrial design process. You have sketching, concept model, detail modeling, and then it goes into Class A, and then it goes to CAD, and then the arguments start, right? So the real arguments actually should start within this design modeling time frame, because that's where the engineering and the industrial design are trying to figure out what's going to fit together and how it all works. And this concept modeling is one of the most interesting places in my mind in the industrial design places, is because if you look at the sketch, and we'll look at a sketch in just a second, but you'll get a few different views of a shape that a designer put together. And people don't, I mean, if you gave 3 sculptors the same sketch, I would be surprised if those 3 3D models would look even close to each other. And why? It's because you have 3 different views or a few views of what that product is looking like, and it's an interpretation of it. So what you end up having is you start with a sketch, and then the amount of data just blows up. It becomes bigger and bigger, and that's a good thing. Now, some people would think that that's a bad thing, but in reality it's good because it gives different views of how the product could look so that the designer can say, oh, you know what, I really like this approach, and I really like this approach, and I really like this approach, and you're fired. But they'll keep on working that way, so they'll be able to isolate to a few good approaches, and they'll keep on working it and detailing it until they can come down to another one. So this funnel sort of does a balloon here, and then it converges back again at the time of after the concept models are done. So I like the concept here. And what happens, there was another slide I could have used, but over time, things have changed. We've gone from the concept modeling is being done with curves, spline definition of it, which is long and arduous, to a point where there's now an approach for doing polygon or mesh modeling for working on the model. So it's a natural place to start to do it, because what happens? You have people that are in the gaming industry that can mesh and push on models to make it work, so they can start to work on the model faster, and that's where the concept modeling comes in. And then we get the fun of creating those surfaces. The reality is you start to cut apart the surfaces when you go into detailed design. Openings for the doors, gaps between the doors, all the hinges and things that make a product work have to be figured out during that detailed design phase. And that's really where this class is focused on, is how do we work on that overall process? So polygonal modeling usually has a whole bunch of little polygons that you start to tweak and modify and form into the shape that you're looking for. Tried and true, pretty much every game that exists now and a lot of the animations that exist are created using some form of these approaches, right? They have mesh models that they use. It's a known entity. The thing is the output is a mesh. It's not a mathematically precise surface. And how do you move from a mathematically imprecise surface to a mathematically precise surface? So I thought that it would be good to show you an approach. And this is our scan data workflow, thanks to Michael. We have a lot of new tools inside of Alias so that you can start to reclaim the surface shape by putting a spline definition. And so here what I'm doing, I thought it would be good to actually have a video of this rather than me doing this, because I can screw things up and then I'd start fidgeting. So what I'm doing here is a mesh subset tool. So I'm just painting onto the mesh, and it's choosing what I have, and it's because I have the normal angle chosen on there. So once I get all of the meshes chosen, and by the way, I often go over the edges, and the nice thing about going over the edges is I can use my right mouse button to subtract those off. So it's like an eraser type mode, and I can change it. So once I get the mesh figured out, the first mesh, then I'll subset it. I'll just hit the space bar to make it subset inside of Alias, and then I'll go to another area, work on that. You'll get the idea. I do 3 of these, so you'll see the process in case you haven't seen this. And by the way, there's more of this up on Autodesk.com under the automotive section, talking about the scan data workflow. All right, one more. And if I could speed it up, I'd probably do that. No. So in 2016, we got the new mesh, kind of the mesh painting tool. And there's a couple things. There's the normal angle. So it's actually looking, as you're going across the surface itself, it's looking at the normal. And within a tolerance of that normal angle determines how much of the surface it's going to grab. There's also the brush. You'll see in this section here, I'm using the brush as an eraser. So I fill out the space and then I erase the lines. And I'm not really worried about the edge here. It can go over the edge a little bit. I don't care, because the next step is just to craft some theoretical surfaces onto that space so that I have some surfaces to work with. Did that answer your question? By the way, you're welcome to ask questions at any time. I'm happy to answer your questions. And if I don't know the answer, somebody will figure it out. No, I'll know the answers, chances are. All right, so our meshes are done. So the next thing is we're going to use a new tool for 2016 as well. And this is the Surface for Mesh tool. And I literally did this not making it perfect, because if I was doing it here, I wouldn't be perfect, so I don't mind. So here I grabbed it. I didn't pull up the options, so now that I have my options, I can choose what I want. In this case here, I'm going to use curvature, which is new as well in 2016. So I select it. It actually selects the whole surface, and that's why I did the mesh, is so that I could define the edges of where I wanted it to go to. And it creates a nice surface on there. And I'm not getting into detail about this. I'm purposely just talking about the fact that if you're using mesh modeling, two things could happen. One is you get a mesh like this that you start to work from. The second one is there are some utilities out there, including an alias. We have the ability to read a mesh directly into alias. And it converts the meshes into a bazillion surface patches that don't have continuity associated with it. So there is a process that you can use. It may or may not be what you are looking for from it.
What's that tool called?
Surface for mesh. Yeah, it's encoded here in this SRF MCH. I like decoded messages. And here I'm just using the normal to grab the top face and the side face, and those would have ended up being the theoretical. Almost done with this. But you get the idea. But I thought it would be good to see what the final surfaces look like here. I'll just hide the mesh and go off to the other surfaces. So as a tech marketer, one of the things I always do is I'll work on this and then I'll cut and paste and make it perfect and keep on doing it until it looks like it's more reasonable. But yeah. All right, so I've gathered it together, and now these are the surfaces I created. So nice, it's a great tool, and it's a good approach when you're working with the mesh data. So rather than bore you anymore with videos, I thought you might actually want to see SpeedForm in operation, in case you haven't seen SpeedForm before. And if I do this right, it takes about 3 minutes for me to create a car. Anybody believe that? Yeah, some of you saw this in the earliest class, so it's unfair to. So here, this is a new wheel arch primitive in SpeedForm, just like a lot of tools. It's always nice to start with some primitives. I'll change the value here to make it go down further on the front and the back. All right, so I've got the basic shape done. I'm going to do a little cleanup on here, which is resolved in the surface patch that's just about ready to go out. What I do. Doing some crease. Now, one of the nice things about SpeedForm is the crease tool. It gives you a nice sharp crease so that you can get your theoretical lines, or you can get to feature lines really nicely. Okay, so that stuff is done. So the next thing I'm going to do is just go to a side view, pull the shape out, extrude it out so I'm actually adding more material out to about there, go to the front view, bring it in, do it again. How many times have I done this, Ananda? But the nice thing about doing it this way here is you get an idea of why people would use a tool, Mesh Modeler. By the way, if you tried to do this inside of Alias, what do you think? How long would it take you to do that? Since I used to demo these things back in the day, it takes, you can do it in about an hour if you can define your curves well enough. So, all right, I got a general idea of what my shape is looking like. So guess what? I'm going to extrude one more time. Oh, I have to extrude one more time. Hold the Alt key down. Thank you, Rex. And then I've got the shapes close to the center, but I'm just going to go ahead and flatten this to the center line. So it's the symmetry will work properly. Put symmetry on it, maybe put some analysis on it. And we've got the start of a model. And then I can just start to define this a little bit more. It's okay for me to play a little bit, isn't it? How many of you have seen Speedform before? About a little bit more than half. Have you ever seen such a good demonstration of Speedform before? I have no personality. All right, enough fun. You get the idea. Quickly come up with the bones of a vehicle that you can then start to build it into something else. This took about 15 minutes in the class, though, so it took a little longer than we wanted it to. All right, back on topic. Actually, that was on topic. So why do you use Speedform? It's just a fast modeler. It gives you the ability to construct a shape very quickly. Working from primitives, you can do all kinds of cool stuff. And from within the interface of Speedform, you're going to see a lot of tools. And we're going to talk about most of these tools, show you directly, show you without actually launching the tools for some, just because I don't feel like spending the time waiting for it. So Speedform data in Alias, which is probably one of the things that attracted you to this class, is what are you going to do, how are you going to be able to use this data in Alias itself. So we'll just go ahead and make sure I don't have Alias running. Tell it to send Alias. So this is a model. It's just built up a little bit further than the one that we just got done doing. And what's happening in the background here, if you look at Autodesk applications, a lot of them now have a send to feature, which allows you to send. It actually does all the stuff of packaging up all the information and broadcasting that out to the application, starting up the application, and if we're lucky, we'll actually see the model come in. I've never seen it not come in, but I have been unlucky from time to time. While we're waiting, any questions? All right, so we've got our model. And I didn't talk about this when I was working on Speedform, but one of the big differentiators between Speedform and the classic mesh modelers is our engine for working with the math surface is a T-spline surface, a specialty format surface that when it comes into Alias, it comes in as real surfaces. So one of the things that I had to help educate our sales team and pretty much everybody else is these surfaces are real. They're very good surfaces. So if we just go through and do some things like pull up a few surfaces, I can turn on the CV hull structure. You can see what they look like. Now, are these Class A surfaces? And everybody should say, no, they're not. These are concept models. But literally, from that model that I just got done creating, I could have that in Alias in 5 minutes. And it takes no time to do this, and I can start to work on it. These are real surfaces that I can work with. What's also cool about these is that if I go in and start checking the continuity, what did I do wrong? Everybody, if those that aren't familiar with Alias, if you see the C on the screen, that means it's checking for curvature continuity. And if it is not green, that means it's not behaving the way it's expecting it to be. And here we've got a green bulb saying that we actually have curvature continuity between each one of these patches. So are these dumb surfaces? You know, maybe, but they're curvature continuous. They're real surfaces, and you can use these to combine surfaces and start to work from it. Can you do a reverse engineering type workflow from this? Sure, but maybe you want to use some curves to start to generate them. So they're real. They're real. And of course, all the analysis tools. Is there a question? Sorry, I thought I heard a question. But you start doing all the curvature analysis tools. You start to bring it in, start to understand how you could actually use these shapes, how you might start to lay out the surface structure for the final structure. Or maybe, this is just a maybe here, maybe you could start using this on the path into the detailed design where you start saying, okay, at this line right here, we're going to cut a door in here, and at this line here, we're going to put another door in, and we're going to start adding this thing here and this thing here, start cutting up the model so that you can break it apart into parts and then worry about how those are going to come together afterwards. So just maybe it's a workflow that could feed directly into the detailed design. But worst case scenario is you recreate it, create the theoreticals, recreate the surfaces from there. Does this make sense? So the nice thing is that natively we're pulling in the spline data from SpeedForm into Alias. So I think that's a good, powerful way to look at the products. Also, any curves that you created inside of SpeedForm, I haven't created any curves in there. The curves themselves will come in here, and then you can use those curves to project or create other surfaces inside of Alias. Another tool that we might want to do is, if you look, helps to be in the right application. If you look in here, there's a form saying send to VRED. So if you haven't seen this before, I'm just going to pull up the VRED scene right away. And this is what you would get if you sent the VRED. So if you're not familiar with VRED, VRED's a real-time visualization tool. Now, I've got some cut planes in here. So the first thing I probably want to do is hide those, get them out of the way. Grab those. How many people have played with VRED? About half the audience. How many do their own visualization work? There's a reason I laughed. It's the company he works for, it's all visualization. Come on. Hide it. Got one more here to get it out of the way so we can see it. So we've got the file directly in from SpeedForm. We can start to decorate it. In case you haven't seen it, pretty simple. Just grab it, drop it. Whoops. Grab it, drop it in there. Get my glass, see if I can find where that's supposed to be. Come on. Well, it has a specially protected headlight on there. Put some plastic on there. All right, you're getting the idea, right? On here, go into ray tracing, anti-aliasing, so you get an idea of what you can do. So I didn't spend a lot of time on this. But the point is when you're in that design phase, both in the concept design phase as well as detailed design, there's design reviews going on all the time. And so having our products have the ability to send to VRED, it takes the pain of doing the translation, getting it sent into the file format, and lots of things that you can do with that. But it's just part of the baseline of the product. So that's another direction you can go with the SpeedForm data, is to look at a realistic view of the product. Questions about VRED before I close it? Going. Ananda, I hear you saying a question. All right, let's keep on going. Any questions about what I'm trying to get to here? Is the path that I'm talking about making sense? By the way, I created a small video on this, downstream use of SpeedForm data that might be helpful. All right, next thing is start to work with the model. So I'll go back to the crazy little model that I worked on earlier, just because it's easy to work on. And in this model, one of the nice things, if I go into a detailing mode, I don't have to get into why, but I can thicken this model into a solid. So let me just make this 2 millimeters. And assuming I didn't screw this thing up, I'll have a solid model of this surface. So we've moved from a surface model to a solid model that quickly. And I'm going to show you a couple places where you can actually be using the solids. Okay, so are we not done yet? Yuji, tell me something. Ask me a question.
Was it possible to convert this speedball shape to mesh and take it to alias and use the surface from mesh and make it better or simpler or bigger patches?
Yeah, so the question is it possible to convert this into a mesh and then move it into the same process? And the answer is yes. The next step of this, for example, would be I might want to go in and do a 3D print of this particular file. So I'll grab this and tell it to create a mesh. So it's a solid. I've got a thickened surface structure, and it's going to do the necessary operations to create an STL file of that. And I could have adjusted what that is and then save the STL file and pull that in. There's an OBJ output from Speedform, so I can output in the OBJ, so just the surfaces from there. So your choice as to how you would like to do that. So here's the ability to do a 3D print of this. Question?
Correct. You eyeballed those from the sketch, so we know the wheel centers are going to be whatever, a fixed distance. So
Yes.
how easy is it going to change that to give you the exact wheel centers?
Great question. So when I created the Rapid product, I went through and eyeballed where they were going to be located. There was a little bit less of a non-accurate placement. If you notice when I did that, I had little dots on the screen. Those are points that actually were aligned to the actual center to center of the wheel. So when I started it and pulled it up. Now what I didn't do, I just eyeballed the actual rings going around. And over on the interface on the right-hand side, you could actually put the absolute radius of that you're looking for. So it's a lot more controlled than I made it look. It's just because I wanted to make it easy to do. And also, when you're putting the sketches into Speedform, there's a calibrate. So you find the locations on it and calibrate it, and actually the sketch actually becomes calibrated to the exercise.
And the other thing is you started off with just some background sketches. What about, we want engineering package data to show the position of the powertrain or the position of the seats and the 95 percentile person. So you pull CAD data from that as well.
Absolutely. So CAD data, any of the forms of CAD data. So for an example, an Oscar could be a wire file where the packaging could be any form, could be STL. Tell the truth, I have the wheels in there. I just didn't show them because I was just trying to make it fast. But all of those are available inside of there. So yes, you can do that. Did I repeat the question? They'll figure it out. I think everybody knows what I was talking about. Sir?
A question regarding the premium of the images.
Yeah.
Scaling of the images. Is that where you can create the fixed points for the wheelbase?
Yes.
Centers? Is that also available within Auto Studio?
Is it available in what?
In Auto Studio where you need canvases and picture planes?
It is a struggle. I agree with you. It generally is a struggle, and I like this mechanism a lot better. The other one is you basically would have to do a grid, and then you align the sketch to the grid structure, and it can be done. It's just not as fun, because on this one here, the nice thing about creating the model from a calibrated sketch is that the model then becomes calibrated, so you can send in, you don't really have, you could actually adjust that back in Alias, but it's a little bit more difficult to do in Alias. But it definitely could be done. We've done it for decades. So, yes. Mike?
Yeah, so, I'm a little different perspective, but when that data comes across, is it then resulting in NURBS hashes in Alias that you can then work with as surfaces, or is it coming across natively in Alias as T-splines
Yeah, we can talk about it later. So the question had to do with how to define the state, so maybe you can get into the mesh form. And the answer is the interface isn't set easily for you to do that. Our interface is set more to try to get the best quality surfaces that you can get rather than having a mesh model. At the same time, if you look at the, if I go into box mode here,
And sorry, this is my first time seeing this, so some of those are probably pretty rudimentary.
there is no rudimentary question. All right, so a mode that I haven't shown yet is this box mode, and this would be the actual patches themselves. So so if there was a way to export this, this is exactly what you're looking for. Yep. So it's there in the code. It's just not exposed to export out. The other thing that you should know about is when I go into detailing mode, and I totally didn't talk about this, but this is now a B-rep representation of it rather than a T-spline representation. So these modes are coexisting with each other. And as long as I'm talking about coexistence, I just hit the 4 key. Oh, it helps to get out of detailing mode. So if I go into this mode here, now I'm into a sub-D. I'm sorry, a simplified T-spline mode. I didn't say sub-D. Take that off the tape, please. But it is. We just introduced the sub-D capability within there. So this is available as well. So it's all just one happy family. Did I answer your question? Did I see another hand from this direction? No. Okay, so let's take the next step in the presentation here. And what I thought would be interesting here is what would happen if in the conceptual design phase is if you had the ability to actually pull the geometry into a CAD system or a simulation system to start to look at potential uses and cases. And in this case here, I actually have 2 use cases going into Inventor. If you noticed, I used the step format to pull it out. So I'm not hiding anything. I'm making sure that you know what's going on here. But I pulled the file in. It's thickened to 2 millimeters. And what I'm going to do here is I'm going to start to work on the grill structure. And there's some plastic feature capability inside of Inventor, so even I was able to figure out how to do this. I ended up cutting out the section that I'm interested in, and then I'll turn it around and I'll start the process of grabbing the pieces to create a grill structure in there. And when it gets all done, it is an Inventor part with the grill, but I can take that grill out, bring it back into speed form, and start to use that to keep on working. And the nice thing about this is this ties, I think, ties directly into the concept of an engineer knows how much volume of air needs to go through the front of the car in order to keep the car from burning up. Right? So the potential is that this could be used for early studies on CFD through these systems to see if it could do this. The second example that I wanted to show was what would happen if I had an instrument panel and I wanted to start to work on plastic features associated with it, because what happens with, how many people work with plastic here? 1 or 2, so a couple. Yeah, so what happens with plastic is if you have the mounting mechanisms onto the plastic as the plastic flows into it, it creates the best way I can call it is an anomaly. It doesn't fill perfectly on the back side, and then you'll get a little a wiggle into the shape itself. And if you can control where those are going to be located, then you can actually start to have a better control as to what that overall structure is going to look like. So that's what we're doing here. We created the bosses on here. I just needed something fast to show that it's capable of doing it. And then because the bosses require that over in this section here. The bosses are actually going over the edge. So we tried a couple ways. And again, we did this pretty ad hoc. So we would have been smarter at it if we were actually doing the work. So can you imagine me trying to do this live before you guys? I'd probably be getting really nervous because that dimension wasn't going on just the way I wanted it, right? So, but this is cool. This is going to be the interior for the 2017 data set that we're going to use this coming year. So I've been working on that for a while. So we'll be able to have things like be able to do plastic flows and CFD flows and things like that to be able to have that pull back into our overall story coming up in this next release structure. I didn't say when 2017 was coming out, so I don't have to apologize for it. Okay, got a couple bosses on there. Make sense? Following what I'm thinking about there? So the question is, do you have questions? Have I given you an idea of that, what can happen to the speedform data as it goes from speedform in there, and the idea of being able to create it? Yeah?
So I'm new to speedform. So can you save variants in speedform for geometry, or do you just duplicate and stack, or is it used as a presentation tool, or would you just keep pumping things into Bread or Alias to do those versions? Because part of the story is the change cycle, right? Change management, variants. Going back to your story of, if you give the same sketch to everybody in the room, we're going to get different vehicles from everybody. Is that a post-process outside of speedform, or can you do those comparisons?
You can do the comparisons. How it's typically done is copy the geometry and look at a side-by-side from it. So, yeah, if I go back into speedform, which one's speedform? This one? I can't be presenting. So if I go back into speedform here, and under the bodies is where it is. So you can organize the bodies into interior 1 or interior 2 or car design 1, 2, 3, 4, and work those through. Yeah, and then the other part that's nice here is that this structure goes into Alias as well as Red, so you can keep track of which pieces of information are going across there. Yeah.
Can you bring in say you have some Class A surface and you're looking to do some new bumpers or side skirts or something like that?
Yeah.
Can you bring in some nice Class A models and blend it with speedform front fascia or something like that, so you can export all that together?
So the question is, can you bring in some good quality data and be able to use it in conjunction? Would you like to see it? Any more questions before we do that? Because the next question Ananda gets to answer. So it'd be nice if you would make him sweat a little bit. All right. Interior, here we go. All right, pull this one in. Okay, you gotta promise me that you'll close your eyes, you won't see any of this information before you. It's a joke. It takes a moment because I've got the complete exterior in here, which is a Class A model. So, all right, it's in, and here's the model itself. So yeah, you can have, this is an Alias Class A model, pulled it in, be able to, I'm actually using this for working on the interior. So yeah, you can use that. You can, there's some things that you can do with it. It isn't like there's a whole bunch of things that you can actually do off the geometry, but you can project edges from there, so you can grab edges and things like that and work directly from it. More questions?
You can modify the import
You actually can. So I can go through and modify this if I chose to. Would you want to? as maybe yeah. So yeah, you can grab this just like any other type of geometry and start to move it like we did earlier.
So, I guess, same loaded question as before. So then is that now converted to the same geometry rules that you live with your interior piece, or are those brought in as, so I guess, do I have a low box representation of that Class A model? Is it amortized out to this? Or, that would be amazing.
Yeah.
So I don't know. Does it do that?
Well, it does do the conversion. So when you pull it in, it is now I believe it's a BREP object inside of here. So it's done the conversion of that. The surface patches look about the same, and the size, this is about 150 megabyte alias file, and it comes in at about 20 megabyte inside of here. So there's stuff that is going on inside of there. So in answer to your question, yeah, it does some conversion, and that's why we can actually do modification of it, is because it's...
You wouldn't want to round trip that back because you're probably losing something.
Yeah, you definitely wouldn't. That's why I kind of asked the question. I wasn't really being coy about it. The question is, you have a Class A model. Do you want to modify that inside of SpeedForm? I don't think that's probably what you'd like to do, unless you're looking for another alternative. You come up with some concepts and then just take those patches, those surface patches that you're modifying, and further develop those. More questions? How have I done? Have I answered, from an expectation? You guys, I haven't heard a word from you guys at all.
Is there a material metadata that you would apply here, or are you really just focusing on geometry?
Yeah, there is material metadata. It's using the Fusion libraries for that, but you can create your own library sets, which I have done. I've created my own library sets, and I just use those. Yep. And if you notice, when I pulled it into Vred, it came in like a black surface, and the glass was kind of a funny blue. The glass is supposed to be a funny blue in here, and if we go into rendered mode, it would look a little bit blue, but it's not fully thought about as it's the final materials. It's more of I'm putting it together. But you know, the renderings coming out of here are not bad. How am I doing? I'm actually on time. How did that happen? I don't know, Yuji. I haven't released this yet, so I'm nervous now. Yep. Like it? Of course, you don't see the headlights, the taillights, and some of the details. And I pulled out a lot of details out of here just because there's grill patterns and all kinds of stuff inside of here that I just didn't want to. Since I was working on an interior I didn't need. So, all right, can't show this anymore. It doesn't exist. It's not real. No, really. I mean, part of it is that with our launch, we like to have a new data set with our launch to really work it. Last year, we had the back model data set. Anybody seen that car before? It's pretty cool. Got two guys here from there, so make sure you say that it looks nice. Seriously, it's a beautiful car. We had that. We had the ability to use that. So this is another one from a trim company. That's your car? Are you from SRG? Oh, tell me that you like it.
I was trying to figure out if there's an R and G, and I was like,
It was just because I cut it in half. So make sure you say hi to Patrick for me. Yeah, and say that I saw your car. It's a lovely car, and the interior looks pretty slick too. So. Yeah, well, right behind there, that's all that mesh work that's behind it. So I took all that out, and same's true over on the side. I took all the meshing out because it's just heavy stuff that conjures up. So yeah, this is it. But Speedform, we'll talk. I'll be over at your office sometime soon. Seeing what? I don't see anything. Seeing this? The cool thing is I love working with customers that'll let us use their data because it gives them exposure. We're going to be able to use trims and all kinds of things that we'll be able to use it. So it's a great thing for everybody that we can use real live demo and say, well, that 250 mile an hour car there is right inside of Inventor here. Let me show it to you, inside of Fred and other things. So now what we need to do is start doing your seats inside of Speedform. Okay? Oh, come on, I'm not hearing it. All right, if I did a good job, no. Fill out the surveys for this class. Somebody looks at them. I don't know if I'm going to, but please fill it out. Blah, blah, blah. Answer bars there. Anyway, thank you for joining us. If you have any questions, please come up. If you haven't figured out, I'm pretty carefree, and we'll answer pretty much every question you will have. So thank you very much.